Hi, so we'll first begin with Java, and I definitely would like to go into the practical aspect first before diving into the more theoretical portion because I guess ultimately at the end of the day you have to write Java programs, so I believe that is much more necessary. So see, I'll every time I write a program, I'll do it in two ways until you get used to it. So the first way is obviously it's using direct Java. Okay, this is the real one. Okay, this is the real one. This is how you would understand how the compilation and the internal process you will understand from this. And the second step, I mean the second way is obviously BlueJ. This is important because this is in your syllabus, and you will also understand why we use applications like BlueJ over direct Java. So both has its own pros and cons. So I'll begin with the normal basic Java. So I'll first give you a structure. So the first thing that you need to understand is that whatever you write, okay, is the basic thing. Whatever you write, the computer code that you write, it is called the source code. Okay. So whatever you are writing right now, whatever we'll be writing, the hello world program and all the things, that is called source code. That is something that is written by us. Okay. Then what we will do is that we will compile this. What is compile? I'll dive into the details later on, but just for your understanding, compile or compilation is the process of converting this source code into the machine code. But here, in just in case of Java, it is not directly the machine code. All right, it is when we compile the Java source code, it becomes bytecode. Okay, so we have two things: source code that you will write. Okay, then we will compile the source code into bytecode. This is the second step, and then this bytecode will be interpreted and finally will be executed. Okay, so this is the last step. Your code runs at this stage. Okay, this is where your code runs and you see the output on the screen. All right, so let's get started with the source code. All right, so every time you write a Java program using direct Java, you have to understand that there is a file. All right, just like you have a doc file or an Excel file or whatever file, you have a file. Okay, the file has a name. The name is important here. Let's say I name this file, let's say um, elephant, I guess. It is important to keep in mind that you keep the first alphabet of the name of the file in capital when using direct Java. Okay, so this is the name of the like the file, that is elephant, but remember to put dot java after writing the name. So elephant.java, this is the file name. Okay, this .java indicates that this is a Java file. This is a Java source code file, and inside this file you will write your code. Okay, then we will what? We will compile it into bytecode. Then the bytecode will be run on your computer. Okay, so this is the process. So this name is important. Okay, so the basic structure of Java program is you have a class. Okay, then you have a main method. You can have many more main method, like sorry, there can be only one main method. Okay, only one main method, and it's important, it's very important. You cannot have more than one main method. Okay, what I mean by that, I'll show you. But you can have many methods with different names, but only one main method. Main method is that public static void main, right what I'm talking about, right? And the class name, the first class name that you have to write should match the file name. So, technically speaking, what was our file name again? It was elephant, right? So our file name should be elephant dot java. This is the file name. Okay. Inside this file, you have to write public class elephant. Okay. Do you see this? The name of the file and the name of the class matches. This is very important. Then you start a bracket. You can put the bracket over here or here. But the main point is that you have to start a bracket, and again you have to close the bracket as well somewhere. I mean, yeah. So it closes right here, opens here, closes it. Remember one thing: whenever you open a bracket, you have to close it, otherwise it will give you an error. Okay. So this is the first step. The second step is to create the main method. The main method is something where Java understands, okay, so this is where I should start executing the code. So the main method looks like this: public static void main and string args. Okay, one more thing. This symbol, okay, I can put it over here, or I can even put it over here. Doesn't really matter. It's the same thing. And again, method also starts a bracket over here, or you can put it over here. Doesn't really matter. But again, when you start a bracket, you have to close it. Remember this thing. Whenever you open a bracket, you close it. Okay, and in the same order. Like you opened it first, you closed it first. You opened it next, you closed it next. So this bracket ends within this bracket. Okay, so this is the outside bracket, this is the inside bracket. You have to understand this thing. Okay, now simple, I'll just write a hello world program. So for writing hello world, you'll just say um, system dot out dot print, and you will say hello world, like this. And yeah, these inverted commas are important. It has to be double quotes. Okay, this is important. And whenever you write a statement like this, you have to put semicolon, not colon. This is the full stop. This is the comma. You know what a semicolon is, right? You'll find it beside the L key of the keyboard. So yeah, once you do this, you have to save this, and then the other process begins. So this is your source code. This is your source code. So remember one thing, just to highlight few things. If you change the name of this, you have to change the name of this. Okay, you can keep whatever you want to keep. You want to keep donkey, you want to keep monkey, it's your choice. But remember, the name of the file and the name of the class has to be same. But the important part is, this over here will never ever change. For every program you write in Java from here on, every program will have this. This is mandatory. This name might change, the elephant part might change, that is perfectly fine. But this thing will never ever change. There will always be a main method. The main method says Java that Java start executing code from here. You start from here. That is the meaning of the main function. I mean the main method. Okay. All right. So let's get started. Let's get started. I'll just create a folder just for you to understand. Again, the first method that I am showing will not be coming into the exams. So this is just for understanding purpose. Okay. By the way, before going into this, I just want to show you how Java runs. So again, three steps. First step, you write source code. You write source code. Okay. Then second step, you compile the source code. You compile the source code into what? Into bytecode. Okay. Then there is a piece of software. Then there is a piece of software called the JVM, which stands for Java Virtual Machine. Now, uh, don't get me wrong, but this is not at all a machine. It is just another software. Okay. So what happens is that you write source code, it gets compiled into bytecode. This is the first step. And then what happens? Then you write another like you another give another command. Then this happens, the bytecode is run. This is the run stage. Okay, this is where the code runs on your computer and you see the output. Okay, so JVM interprets this, interprets. Now there is a difference between compilation and interpretation. I'll go into that in a bit. Okay, so let's first write the program. So you can open notepad, no issues with that. You can perfectly open notepad. Yeah, cool. All right, let's write this Java program. All right, so Let's first you have to save it. So you hit Control S. Remember, if you're using direct Java, save as type, go here and just select this one, all files. Okay. Now oh, okay, it's already here. I'll just write some another name. Let's say I am giving the same name, elephant. Notice the E is capital. Dot Java. Okay. You save this. Now this is the Java source code. All right. So now you write the code just as it is, just like I showed you. So public class. What's the name of the file? Elephant. So public class elephant. All right. You start the bracket and you close the bracket. This is important. Did you see this? I started the bracket. I ended the bracket. Keep it down. Then you hit a tab or space or whatever you feel like. But you should give a space. Even without a space, this will work. But you should give space so that you can clearly understand the code. Otherwise, it will be more confusing to you. So now public uh, static void main. Remember, this will be same for all string args. You can put the bracket over here. You can also put the bracket over here. It doesn't really matter. Do this again. You open and close the bracket. Okay. Do the same thing. Put the tab. Now within this, you will write your code. Okay. You can type in more spaces. You can remove spaces. Java doesn't really care about spaces. It cares about the brackets and all the semicolons. So system dot out dot println or just print hello world. It's that simple. Okay. You save this. So this is your Java source code. All right. So where is it saved? Where is it saved? I think I have saved this. Let me check. Let me check. I guess I have saved this into this folder. All right. Fine. Fine. I'll go to that folder. Just give me a moment. So coding and you just go to this folder Java. So this is our elephant.java. Let me remove these things. So this is our source code that you have written right now. Do you see the type is Java source file? So whatever you write, it is called the Java source code or the source code simply. So now the next step is you click over here and type in cmd. Cmd. Okay. It will open something, this black screen. This black screen is called the command prompt. Okay. Now don't take this all very seriously because this is not the way you will write code. This is just for understanding the way Java works beyond your screens on the background. I mean, okay. So now, just to show you, um, okay, let me do this another way. Let me do this another way. Yeah, cool. So, do you see we have only one file, that is elephant.java. So what's the first step? We compile the source code. How to compile the source code? Use Java. Do you see the C? The C stands for compiler. So you call the Java compiler and you type in the name elephant.java. All right. So you're calling the Java compiler and telling it to compile your source code into bytecode. Now you hit enter. If your code is correct, then it will not give you any error. It will simply just execute. Okay. It has been compiled. How do you know? Do you see there is now another file? And what's the type? Class file. This is your bytecode and it really looks ugly. I mean, if you try to open this using notepad, you will not understand this thing. This is your bytecode. Humans cannot understand this, but JVM can. Okay. This is the second step. Now why bytecode? The thing is that right now I am using my laptop to compile this, right? If I give you this file, you can run this file on your Android phone. I can run this on an Apple iPhone. I can run this on any device in the entire world. That is the motto of Java. Write once, run anywhere. Okay. So what's the second step? The second step is that you have your bytecode, right? The second step is running the file. How do you run the file? You say Java. This time, do you see? I did not say Java. I didn't call the compiler. I just said Java, and I'll just say elephant. Do not put dot .java. Do not put dot .java because dot .java is the source file. You don't need that. Just say Java elephant. Do you see? It's printing up hello world. So what are the two steps? First thing, you write the source code, you compile the source code, and it becomes bytecode, right? What's the bytecode? This one over here. This is the bytecode. Dot class. This is the bytecode. Then you call JVM. Whenever you write Java, it calls the software which is the JVM, Java Virtual Machine. Java Virtual Machines run this code and it gives you the output. Now, Java is platform independent, meaning um, whenever you compile the file, whenever you compile the file, it will look exactly like this. Doesn't matter wherever I compile, my laptop, your phone, doesn't matter. Okay, it will always look like this. And special part is that if I give you this file and you just say Java elephant, it will give you the result. Even if it is if it is your laptop, it will happen. But the same case will not be true for other programming languages like C or C++ or some other compiled languages. Okay. So now so this is the basics of Java. Okay. This is I have used the first method, that is the direct method. You don't have to do this. This is just for understanding purpose that Java works in multiple steps. The first step, you write the code. The second step, you compile the code into bytecode. The third step is you finally execute the code via JVM. I hope you got the flow. Now let's get into the details of compilation and interpretation. Okay, let's understand this in a more detail. Let's create a new page. I hope this is clear to you. All right. So what is Java? What is Java? Java is a programming language, right? What is a programming language? Programming language is a language which the computer understands, right? But how? How does a computer understand Java? So, just for example, let's say I am a guy who knows only Hindi, okay, and I travel to, let's say, Japan. I cannot speak Japanese. I cannot speak Japanese, right? So I need a guy. I need a person who will convert my Hindi into Japanese. This guy is called the translator. Similarly, a computer can only understand two things: 0 and 1. 0 stands for off, 1 stands for on. That's all the computer understands at the end of the day. So Java, as you can see, Java is a language. You are writing it in kind of English language, right? So how can computer understand this? So Java has to be converted into the computer's native language. This thing is done by you know the uh, the compiler or the interpreter. The compiler or the interpreter. Think of it like a translator. Okay. So there are two ways of doing it. There are two ways of converting a programming language. Forget Java. A programming language into computer's native language, which the whatever the computer understands, right? Programming language is in English, kind of. I mean, yeah, you are writing it in English, kind of. But computer language is in zeros and ones and all the low level stuff that is going on. So you need a converter. You need a translator. This translator can be of two types. The first type is compiler, and the second type is interpreter. Now let's dive into the details of each. So the first one, let's say uh you this is you have written a letter, and let me write this like this. Okay, so the letter contains, let's say, hundreds of lines. Okay, hundreds of lines, too many lines. Okay, and you want to give this letter to the principal. Now you obviously want that there should not be any mistakes and anything. So you have two friends. The first friend is your compiler, the second friend is your interpreter. So you give this letter first to compiler. You tell him, bro, check my letter, check if there are no errors. and only then I'll give it to principal. So what does compiler do? Let's imagine uh, you have a error, you have a grammatical error here, you have a spelling mistake here and everything, okay? What compiler does, it will start reading. It reads the entire thing from beginning to the end. Although it detects error here, it will not come to you saying you have an error in line 3. No, it will keep on reading this. It will detect another error, but it will not come to you. It will keep on reading. Okay, it will read the entire 100 line, and after that, he will come to you and say line number 3, line number 4, 5, 6, line number 6 has errors. This is the job of compiler. What compiler does, it reads the entire thing, okay, entire thing, and then it gives you the errors. If there are no errors, if there are no errors, compiler converts the code into machine code, okay. This is compiler, okay. This is what compiler does. Now what does interpreter do? What does interpreter do? Let's use green color for interpreter. So now you give the letter to interpreter. What does interpreter do? Reads line 1, reads line 2, detects error in line 3. It does not go beyond that. It will stop here and it will say line 3 has an error. Fix it. Fix it. Okay. Unless or until you fix it, it won't go to the next line. So you fixed it. It will continue. First, second, third, then fourth, fifth, error. It will stop here. It will not go after that. It will tell you now that L6 has an error. Fix it, you correct it, and then we'll go on like this. Okay. So this is interpreter. Interpreter goes line by line, line by line. It reads your codes line by line and converts it to machine language. What does compiler do? Compiler reads all the lines, all the lines, and interpreter line by line. Okay. If there are error, compiler will only tell you after reading all the line. Interpreter will tell you immediately, like immediately whenever it finds error. This is the difference between compiler and interpreter. Hope this is clear. Now let's come to programming language. The programming languages can be of three types. The first one is obviously pure compiled languages. Compiled. This is the first one. Compiled languages. The second one is interpreted languages. Okay. Then there is a third kind called hybrid languages. Okay. So first let's begin with compiled language. What are the examples of compiled languages? The most common is C and C++. C++. Um, so C and C++ is a purely compiled language. How does C and C++ work? Okay. Again, you have a source code. You have a source code. Okay. And you call the C compiler. No, not the Java compiler. You were writing in C or C++. You call the C compiler or the C++ compiler, whatever. Okay. So you call the compiler. Compiler reads the entire thing, just like compilation works. Entire source code. If there are 100 lines, it will read the entire 100 lines and tell you if there are some errors. If not, the entire thing will be converted into machine language, which we call object code. Object code is basically the machine, whatever the machine understands. This is it. Object code. Okay. So it will read the entire thing and convert it to object code. You can run this. You can directly run this. Okay. It will run. Simple. It's run. Okay. It's very simple. The problem with compiled languages is that these are like um, platform dependent languages. For example, you have this phone, you have this laptop. Okay. Okay, cool. So you're writing a program in C++, let's say, and you're compiling it in the phone. You get the object code. You write the source code in phone. You compile it. You get the object code. That's perfectly fine. Now the issue is that the object code in this phone will only run in this phone. If you give this object code to this laptop, it will not run. It will not run. This is platform dependent. C and C++ are platform dependent. Most of the compiled languages are platform dependent because they directly convert to machine code, only made for your machine, only made for your machine. It will not work in any other machine. Okay, so this is what uh, compiled languages look like and work like. Okay, then let me go back. Let me go back. All right. Then we have interpreted languages. All right. We have interpreted languages like what are purely interpreted languages? Let's say Ruby. Ruby is a purely interpreted language, or even Python. You can take that. Although Python nowadays is no longer interpreted, but let's say Ruby and Python. These are purely interpreted languages. Again, you have a source code. All right. Now you do not call the compiler. There is no compiler. It's interpreter. You call the interpreter. What interpreters with interpreter there is no concept of object code. It will directly take your line of code, convert it, and run it. Directly take your line of code, convert it, run it. Take your code, convert it, run it. So one by one it will go. It will read. It will convert. It will run. It will read. It will convert. It will run. So this is interpreted languages. Okay, and yeah, yeah. This is how it works. This is how it works. So there is no concept of platform dependency here because there is no concept of object code. The only thing that you can give is source code. There is no object code in interpreted languages. Then 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 comes our next thing, hybrid languages. Java is a hybrid language. C sharp is a hybrid language. Now both of these things work in a similar way, but I'll go with Java this time. Okay, just to make you understand. So how does Java work? I already told there's a source code. I mean, whatever you write is the source code. Okay, I'm repeating multiple times so that you can get this. Source code is whatever we write. Now, the first step in Java, we compile it. All right, we compile it into what? Into bytecode. We compile it. What is the process called here? The first step is compile. Oh, I used the wrong color, lol. Hold on. Let me use yellow. So compile. Then then we call uh, the JVM, right? We call the JVM, and the JVM takes the bytecode and what? JVM interprets. JVM interprets. Okay. So first step is compile. It will compile the source code into bytecode. Then JVM takes the bytecode and interprets. What is interpretation? A bytecode, obviously, like you have source code, you have many lines. A bytecode, you have many lines. So what JVM does in the bytecode, remember, in the bytecode, it will go line by line. It will run, execute. It will read, convert, execute, read, convert, execute. Whatever that was happening in this part, it will do the same thing. So the first part is compilation, which will be done by Java or the Java compiler. And the next part is interpretation, which will be done by JVM, Java Virtual Machine. So this is how Java runs. Okay. Hope this is clear. Okay. And so basically, let me open BlueJ if it works. Cool. Do I have BlueJ installed? Let me check. It's been a while. Yeah. Yep. I have BlueJ. Oh. Anyways, I'll create a new project. Whenever you open BlueJ, I'll definitely show you in a much more better way. But you open BlueJ, you create a new project. Okay. Now you can create. You can name the project anyhow. Let's say elephant. Okay. So elephant. I create the project. This is my project, right? So the first thing I need to do is to select new class. New class. Let's keep the class name as elephant. Okay, it should be class. Okay, the first thing is class. Remember, the first thing has to be class. Select OK. See, there's this elephant class. If I double click it, it will open. Now, see, it makes easy for you to write code. That is why you are using BlueJ. It is making easy. It will help you to learn it in a much better way. Do you see this? Delete all this stuff. You don't need this. Delete all this stuff. Now, what you need to write here: public static void main. Okay, string args. Again, put the brackets anywhere you want. Open and close the bracket. Within the bracket, you will type in what? System.out.print and say hello world. End of the story. Fine. Now, see, do you see this button? What is this? This is compile. And how did we compile last time? If you remember, we called Java elephant.java. It is the same thing happening in the background. You won't see this. You won't see this, but this is the thing that is happening. And what we are writing, this is source code. Do you see this? This is source code. So compile this. If everything is right, it will show class compiled. No syntax error. Do you see this? So how do I run this? Let me check. Yeah, right. I'm back. Sorry. Yeah. So you just close this. Okay, no need. You just go here and right click, and do you see this void main? Do you see this? Just click here. Just say enter. See, you get hello world. So it's running properly. Okay. So this is how you write code using BlueJ. Just hit OK. Yeah. Oh yeah. Do you see this? Do you see this? Since you're using like print statement, it's just printing it multiple times in the same line. If you do not want this, what you can do, go here and type in print ln. What is ln? Ln means new line. Okay, or just line. So you can save this and compile. It will compile. See, class compile, no syntax error. Again, close this window, right click, void main, run this, hit OK. This is the first time, and see, now it's coming in the next line. So now every time you run this, it will come to the next line. See, it's next line. So if you want the output to come to the next, just the next line, use the ln. Use print ln. I prefer this one. Basically, print ln is my preferred method. So I'll probably use this much more than print. So yeah, this is your hello world. All right. Then in the next chapter, we'll definitely go into the details of uh, uh, you know data types and variables. How do we use variables and data types and all those things? What are the limits and everything? So this was the beginning introduction of Java. Hope this is really clear to you. If it is not clear to you, please contact me. you know how to reach out to me. You have my email and everything. So just give me a email, drop a mail, or give me a call, whatever you like. Okay. So thank you so much for bearing the entire lecture with me. See you in the next lecture. Bye bye.